Hi, it's Professor Davis again, and this is your topics checklist for Module 7. Module 7 starts Chapter 4, and that's on polynomial and rational functions. So in this module, Module 7, our focus is on the polynomial functions. The first two sections focus on the quadratic functions. So let's talk about those for a minute. In Section 4.1, we want to be able to use the graph of a quadratic function to find various things for it. First, the coordinates of the vertex, the axis of symmetry, and that'll always be of the form x equals the x-coordinate of the vertex. The intercepts, those being the y-intercept, that's easy to find. That's just f of 0 of a quadratic function, the value of f of 0. And the x-intercepts are found by setting the function equal to 0 and then solving the resulting equation, and that can be done through a technique like factoring or by using the quadratic formula, and then finding the domain and range of a quadratic function. And remember, the domain is always the set of real numbers for a quadratic function, and the range is determined by the minimum or maximum value, whether the graph opens up or down, and that's that y-coordinate that determines the range. And so you might want to look at example 1, and there's a great animation on this on ebook screen 4.1-6. So make sure you look over that. Also in this section, we want to be able to rewrite a quadratic function in standard form by completing the square, and by the standard form, we mean the form f of x equals a times the quantity x minus h quantity squared plus k. Now, I'll also have a mathcast available that will show you how you can use your graphing calculator to do the same thing, to write a quadratic function in standard form without completing the square. So you can always check your work that way. And then we want to be able to determine a quadratic function given its graph. So there's two pieces of information we need. We need a point on the graph, and we need the vertex. So once we do that, we can determine any quadratic function. The vertex is critical, though. So in that section, in section 4.1, we want to do practice exercises 1 through 25 odd, and then 31. Those start on page 167 of your summary notebook, if you have that. For the ebook, that starts on ebook screen 4.1-22. Now in section 4.2, we move to the applications of quadratic functions. And there's really basically three of these that we want to look at. First, in examples 1 and 2, there are examples there on projectile motion problems using the gravitational constant and so forth. And then we want to look at maximizing revenue and profit functions. By maximizing, we want to find the f of x value, the function value, at the vertex. Now, so make sure you look over the definitions of a revenue function and a profit function. The profit function is always found by taking the revenue function and then subtracting off whatever the cost function is. So make sure you look at examples 3 through 5 there. And then there's an application on maximizing area functions. Now, you might want to look at that in example 6, and also there's an animation that will help you there too. So for homework to practice exercises, we want to do problems 1, 3, 4, 5, 6, 7, 9, and 11. Excuse me, those start on page 176 in your summary notebook, and ebook screen 4.2-24. And then finally, to finish off this module, we want to look at the graphs of polynomial functions. First thing we want to be able to do is to differentiate polynomial from non-polynomial functions, and that's shown in example 1. And then also we want to be able to do various general things for polynomial functions. We want to be able to find what's called its end behavior. In other words, what do the function values do as the x values get negatively and positively large? We want to be able to find the intercepts, the values that make, with the values where the graph crosses the y-axis and the points where it crosses the x-axis. And then that goes along with the real number zeros, that goes hand in hand with the x-intercepts and the multiplicities of those, meaning sometimes we get repeated solutions to a polynomial function, so we want to be able to indicate that as well. And then I would strongly urge you to look at the four-step process to sketch the graph of a polynomial in example 6. And so in section 4.3, we want to do homework to practice exercises 1 through 6, and then 16 through 33 odd. Those start on page 199 on the summary notebook, and the ebook screen 4.3-37. So that is your topics checklist for Module 7.